1473, paid houses 3. So for this problem, we are giving an array of houses. So this 0 means the house is not painted. If there is a number, for example, this is 1, it means the house is painted with color 1. And if the number is 2, it means the house has already been painted with color number 2. But finally, all the houses should be painted. Yeah, I mean, it should not have 0. Yeah, if it is a 0, it must be painted. If it is like 2, 1, 2, those 3 should not be painted. Yeah, we just need to paint the zeros. Yeah, and we need to calculate the minimum cost of painting all the remaining houses in such a way that there are exactly target neighborhoods. So what is the neighborhood? Yeah, how it is calculated? So it is calculated like this. So for example, if the target is 3, it means we need 3 neighborhoods. So after painting, the house will be 2, 2, that is 1 neighborhood. So for this one, this is another neighborhood, and the last 2 and 2 will be the last neighborhoods. So there will be 3 neighborhoods. Yeah, and then we're gonna need to understand this line. I think the house's eye is the color of the house, and it's easy to understand. And 0 means the house is not painted. Yeah, and this line we need also to understand. The cost IZ is the cost of paint the house I. So for example, I equal to 0, it is the 0's house with the color J plus 1. Because if this J equal to 0, because the color is painted starting from 1, so it is the J plus 1. So J normally in the cost array it's gonna starting from 0, but with the color J plus 1, it means the color will be starting from 1, and then it's gonna be 2. Yeah, because 0 means not painted. Yeah, so for the first color, if we want to paint, like we're gonna paint like 1, 2, and it should not be like 2, 3, or 4. It must have 1 first, and then 2 and 3. Yeah, it always depends on this J. Yeah, if J equal to 0, it means the color would be 1. If J equal to 1, it means the color would be 2. Yeah, you need to understand this line, otherwise it's going to be difficult to solve the problem. Yeah, let me first go to the whiteboard to explain the problem a little bit. So for example, this is just the houses. So the black area means the house is not painted. So for example, if this house is painted, so the color gonna be yeah, let me prepare some color. Let me prepare some blue color maybe. Yeah, so the color would be blue. So this color would be painted, and then I'm gonna use this. Yeah, the next house, it is not painted, and then it is not painted. Yeah, now I'm gonna set the first house also to blue. Yeah, so as we can see for this array, the first house and the third house has already been painted, but for the second, the fourth and fifth house has not been painted. Now we are going to paint it. If we have only 2 colors, we can choose. So the first one is blue, maybe the second one, the first one is blue, so the second one, yeah, I'm gonna choose red. Yeah, now for the first house, we don't need to paint it, it is okay. Yeah, and is there any cost? No, because we didn't paint the house, so there's no cost. Now we come to the second house, and we wanted to calculate the minimum cost. So we can choose what color we can choose. Can we choose blue or red? Yeah, maybe we can choose one of them. Yeah, because the target I will set it to 2. Yeah, because we didn't exceed the target. So for example, if we choose to color it as blue, but blue here, this number 1 means blue, so we can get the value from the cost array, because the cost array is just a 2D array. From the cost array, we can get the value, get the cost. Yeah, so we're gonna paint it as blue, and then we go to the next. It has already been painted, it is okay. Now we go to the next. So for the next one, what color we can paint? Yeah, we can paint it like blue or red. Yeah, we can paint either of them. For example, if we just choose to paint it as red, what's gonna happen? So we paint it as red. Yeah, and now what's gonna happen? We got another cost. This cost is coming from the red color. Yeah, because the cost is a 2D array, we can get the value. Yeah, but what about the last one? for the last one, can we choose to paint it as blue or red? Yes, we can, because we can choose to paint it as red. That is okay, because we have two groups. The first group is blue, the second group is red. But can we paint it as blue? No, we cannot. If we paint it as blue, so we're gonna have three groups. So this is the first neighbors, and the second neighbor, and the third neighbor. Yeah. So this means while analyzing the problem, we need to check what is the previous color of the house. Yeah. Because we need to track the neighbors. Yeah. So if this is a blue, for the next one, if it is still blue, so this means we still have neighbors of one neighbors. Yeah. Now it is still blue, we still have one neighbors. Now if it is red, it means this value, this color, not equal to the previous color, this one. It means we found a new neighbor. So 1 should plus 1, we have 2 neighbors. And now for the next, yeah, if it is still blue, so it will plus 1, we're gonna have 3 neighbors. But our neighbor is 2, it means we cannot paint it as blue, we have to paint it as red. So if we paint it as red, now how many neighbors do we have? We have 2 neighbors, only these 2 neighbors. Yeah. Now we have 2 neighbors, it means we have reached our target. So our target is 2, and what gonna be the result? Yeah. So the result is just calculated by using DP. So for the big problem, it's difficult to solve, but we're gonna split the big problem into smaller problem until we can solve it. Yeah. So the edge case is that if this index I, so I'm gonna prepare the index I as my houses. So if the index I go to the out of the array, equals to the length of the array is m for our question. If it is equal to m, it means yeah, it reads out of the array. There's no houses. We don't need to paint it. So we have to check our target. If our target t equal to the final target, it means the neighborhoods. If the neighborhood is 2, our target is still 2. So we're gonna check the final result. Yeah. So the final, we're gonna check the final answer. But for our solution, I'm gonna use the DFS plus memorization because this is easy to understand. And I just gonna return a 0 because I go to the end. There's no houses. I gonna return a 0. Yeah. So if the target, for example, if the target not equal to, if this t not equal to my target, yeah. So what I gonna return? But I still go to the end of the array, go out of the array here. Yeah. What I gonna return? I gonna return positive infinity because I wanted to always choose the minimum value. So I need to return positive infinity. Now let me go to the code editor to finish the coding. So for the problem, I'm gonna prepare a case because I'm gonna use the DFS. Yeah, and because it is a DP problem, so I need to use a case. So for the first position, I'm gonna use the index, and the second position, I'm gonna use the last. It means my previous color because I need to track what is my previous color in order to get my target. Yeah, so t as my target value. Yeah, so this is gonna be my DFS. Yeah, so I'm gonna check if this I equal to m. So m is the houses. If it is equal to the houses, so I'm gonna return a 0. So if the t equals to target, yeah, else I'm gonna return infinity. Yeah. So let me explain what is the meaning for I. So I is the index of houses, and the last just means the previous house color, and the last one t is initial neighborhood. Yeah, initial neighborhood. So this is the definition of those 3 variables. Yeah. Now, in order to speed up a little bit, I need to check the target. Yeah. So if this target my target starting from 0. If it is more than the target, more than the neighborhood, so I gonna return infinity. Yeah, I just let it run a little bit faster. So I just check this kind of yeah, this is just like trimming. So normally for the DFS, if you can find a way of trimming, you can always trim it. If you can't find it, it is still okay. If you don't use those lines, it is still okay. Because it is a DP problem, we already used the memorization. Yeah. Now we are going to check each of the houses. Yeah, I'm gonna use color. So for let me check. I need to check if there is a color for this house or not. Yeah. So if houses I is the index equal to 0, this means I need to color the house. Yeah. Yeah. If it is 0, this means need to color. Yeah. If I need to color the house, normally I'm gonna use the brute force to check all the possible cases. Yeah. So for color in range from 1 to n plus 1, because n is the color, so n plus 1, I'm gonna starting from 1, because this is according to the question, the color is just starting from 1, it is not 0, because 0 just means the house has not been painted. If it is painted, so the color would be starting from 1 to n. So here I'm gonna use n plus 1, means the color starting from 1 to n. Yeah. Now, let me prepare a result as starting from let me check. Because I'm gonna choose the minimum value, so the result would still be the infinity. Yeah, I think I'm gonna prepare the result as infinity, because I still gonna choose the minimum value. So it's gonna be the minimum of result with DFS. So DFS, it will go to the next house. Yeah, because for this house I'm gonna paint it with this color. Yeah, so gonna go to the next house, and what's gonna be the color? So I'm gonna record this color, so it's gonna be the color. Yeah, and what is my target? So target is t. T needed to plus. Yeah, I need to check if this color equal to the last or not. Yeah, so I need to check my current color. If it is not equal to the previous color, I need to use t plus 1. Yeah, because this is the neighborhoods. I know the neighborhoods. If they are not equal, so t should plus 1. If they are equal, so t should plus 0. I would keep it. Yeah. So this is the DFS. But for the DFS part, we need also to plus the cost. Yeah, so the cost array is cost I to the color minus 1. Yeah, because according to the question, the color is starting from 1. But actually for the cost array, the index is starting from 0. So here I need to use the color minus 1 as the meaning of my first color. Yeah. For example, if it is a 0, it's the first color. So if color equal to 1, 1 minus 1, it is a 0. It's my first color. Yeah. So this is for house equal to 0. And another case is else case. Yeah. So for else case is no need to color. Yeah. No need to color. Yeah. If there's no need to color, what is it gonna be? So for here, if we need to color, we still need to return the result. Yeah. So we're gonna check all the minimum cases, and finally, we're gonna return this minimum value. Yeah. Else, we're gonna return the DFS with I plus 1. Go to the next. And what is my color? So my color would be houses. I is my current color. Yeah, because I need to record it, and I need to also compare with the last color. Yeah. And what is the t? T should plus. Here I'm gonna check the my current color is just houses I not equal to last. Yeah, here you can see it's gonna be the same, but here I don't need to plus the cost because I didn't paint it. If no need to color or no need to paint, yeah, needed to paint. Yeah, it's gonna be just to return the DFS with the next house, and I record the previous color of the house, so it is the current color, so I'm gonna record it as the previous color, and this T would plus to the house's I not equal to the last color. Yeah, if it is not equal, T plus 1. So if it is equal, it's gonna still be T. Yeah. So finally, yeah, I don't need to return because I've already have all the return. Yeah, I think this is the entire code. So finally, I just need to return the DFS starting from 0, and for the last, from the beginning, I'm gonna give a -1. Yeah, yeah, just in case there's no -1 from the last, so I'm gonna give a -1. It means for the first one, I don't need to check if I have a previous color or not, because for the first one, yeah, I don't have the previous house for the first house, and I'm gonna have a target starting from 0. So this is yeah, the entire code. Let me just run it to check. So the index of house last previous invalid syntax. Oh, what did I do? Maybe I just needed to delete this delete this blank area to avoid the syntax error. Yeah, let me just put the comment here. Yeah, let me just put the comment here again to check what is wrong with it. Yeah, because I didn't put the DFS. Yeah, it should be def with the DFS. Yeah, let me just check if there's anything wrong with it. Yeah, now it should be okay. Yeah, now it seems okay. We passed the first and second case, but the third case didn't work because I give a infinity. It should be -1 because I didn't check it. So this means from here I can check it. So from here I'm gonna record the result as the DFS. So I'm gonna return result if result not equal to infinity, else I'm gonna return a -1. Now let's just run it to check. Yeah, as you can see now it works. Now let me submit it to check if it can pass for all the testing cases. Yeah, as you can see it's pretty fast. It's like 1 second and it passed all the testing cases. So from here, let's do some testing. If we do not use the T, if we do not use the T more than target, what's gonna happen? Yeah, I believe it should still work. Yeah, because it's a DP problem. But let's just check. As you can see, it still works. Maybe there's not so much influence. Yeah, as you can see, the time is still the same. Yeah. Now let me run again. Yeah. Now I think we can, yeah, as you can see, it's a little bit faster, maybe. Yeah, but it's nearly the same. Yeah, because it's a DP problem and it's a 3-dimensional problem. Normally, this should not have so big influence. Now let's analyze the space and the time complexity. The space complexity is easier to analyze because we just have 3 values. Yeah, I, last, and t, and we have a cas. Cas is just like a dictionary for Python, and this I is n, and the last is for the color is m, and this t. Yeah, let me just check this t. Yeah, t is also m. So for the space complexity, it is n times m squared. Yeah. Now let's just check the time complexity. For the time complexity, because we still need to use this I, last, and t, these 3 variables, but we also need to check this 4. It means we need to add another color. Yeah. So for this I, it is n. I is m or n. Yeah. I think I is m. So I is the number of houses. I is m. And the color is n, so this is n, and the last is also n, And what about the t? And t is the target, t is m. So this means the time complexity would be m squared times n squared, because we have 2m and 2n. Yeah, so this is the entire code. If you are not familiar with the multi-dimensional multi-dimensional DP problem, I think you can start with this problem. Although this problem might be a little bit harder, because you need to take care of the previous color of the house. Yeah, if you know about that, this should be easier to understand. Thank you for watching. See you next time.